Hi everyone, today we will discuss about the chapter 3, which is the problem solving. The topics are inductive reasoning, deductive reasoning, problem solving, and the problem solving strategies. First, inductive reasoning. Inductive reasoning is also known as induction. It is when you make conclusions based upon current knowledge, observations, and patterns. The conclusion you draw from inductive reasoning is called a conjecture. A conjecture is not supported by proof. It just take one example to disprove conjecture. This example is called a counterexample.
Inductive reasoning is used in geometry in a similar way. It is a type of reasoning that forms generalization or conclusion based on the examination of a specific example or a specific instance of events. So, what is the goal of inductive reasoning? The goal of inductive reasoning is to predict a likely outcomes.
Inductive reasoning is a type of reasoning that involves drawing a general conclusion.
So when we say inductive reasoning, it makes broad generalization from specific, and it uses patterns to arrive at a conclusion, which is called conjecture. Example: find the next three exceeding terms of 2, 4, 7, and 11. Given the sequence, 4 minus 2 is equals to 2, 7 minus 4 is equals to 3, 11 minus 7 is equals to 4. The difference between the two consecutive numbers is increased by 1, so just add number 5 for us to find the next pattern and find the preceding terms and so on.
First, generalize. This is just a simple example given above with the white swats.
It asserts that what obtains in these known instances can be generalized to all. It is known as enumerative induction, the earliest form of inductive inference, and it has been elaborated in various ways, largely with the goal of extending its reach. Second, statistical syllogism or propositional syllogism or direct inference. It is a non-deductive syllogism. It argues using inductive reasoning from a generalization due for the most part to a particular case. Simple induction. It is also called weak induction. It proposes that extrapolation be treated as a default inference among populations that are related in some appropriate sense. Fourth, argument from analogy. It is a special type of inductive argument whereby perceived similarities are used as a basis to infer some further similarity that has yet to be observed.
This form notes on a basic of shared properties between two groups. They are also likely to share some further property.
Causal inference refers to an intellectual discipline that considers the assumptions, study designs, and estimation strategies that allows researchers to draw causal conclusions based on data. 6. Prediction draws a conclusion about a future instance from a past and current sample. It relies on a data set consisting of specific instances of a phenomenon.
These types of reasoning draws a conclusion about the future based on a past simple
Argument from authority. Also, a authoritative argument and appeal to authority is an inductive reasoning argument that often takes the form of statistical syllogism. Last, Bayesian inference. It is a method of statistical inference in which Bayes' theorem is used to update the probability for a hypothesis as more evidence or information becomes available. So, that's are the types of inductive reasoning.
Examples and predicting the next number. We have this number 3, 5, 9, 15, 23, and 33. So what would be the next number? Let's check this part, the difference. We could say this is the raising out of 1 is that the difference or the predicting difference is added more than 2. They're going to have 2 has the first difference and 3 and 5. So 2 plus 2 is equals to 4. The next one is 6 8. So 10 plus 2 is equals to 12. 33 plus 12 is equal to 45. That is the reason based on the specific example in inductive reasoning with the sign that the next number is 45. Let's have an example and state a generalization. Generalization is like a formula. Let's have this number 5, 10, 15, 20, a's of n. We call each of these as a term of a sequence. The 4 elements is the multiple of 5. 5 times integers. 5 is 5 times 1, 10 is 5 times 2, 15 is 5 times 3, 20 is 5 times 4. So, the general term is a's of n equal 5 times n.
Inductive and deductive reasoning are two fundamental forms of reasoning for mathematicians. When we say deductive reasoning, it is a process of reaching a conclusion by applying general assumptions, procedures, or principles. Or we can say the process by which the way of showing certain statements follow logically from a great assumptions, proven facts that there is a need to justify every step with a reason. For examples.
Example number 1.
If a number is divisible by 2, then it must be even. Okay, 12, as you can give any even number. 12 is divisible by 2. And that is true. Therefore, 12 is an even number.
Example number 2.
If angle A and angle B are supplementary angles, their sum is 180 degrees. And if measurement angle A is equals to 100, then measurement angle B is equals to 80 degrees.
Another use deductive reasoning to establish a conjecture. For example, pick a number, multiply the number by 8, add 6 to the product, divide the sum by 2, and subtract 3. So, our goal here is to find the procedure. Let's say n represent the original number. First, we need to multiply. So, pick a number, multiply the number by 8. So that is 8n. It's 8n. Add 6 to the product. Divide 2 is equals to 4n plus 3. How? 8n divided by 2 is equals to 4. 6 divided by 2 is equals to 3. Therefore, 4n plus 3 minus 3 is equals to 4n. Therefore, we're going to say for that, we started with n and ended with 4n. The procedure given in this example produced a number that is 4 times the original number.
A is equals to B. B is also equals to C. Therefore, A is equals to C. Another example, if a number is divisible by 2, then it must be even. 18 is an even number because it is divisible by 2. Deductive reasoning is commonly used in geometry. In high school, students always encounter tables with statements and reasons. And most of the students only know that the reason for the statement is the given. This is an example of applying deductive reasoning, where you are going to find a statement and reasons from the given statement. first statement is the given. And we can distribute the 3 from the quantity. So it will become 3x plus 12 minus 2x is equals to 20. And the reason for this statement is distributive property. Next one, you have to combine the common terms. So 3x minus 2x is equals to 20, and that is commutative property. The next one is x plus 12 is equals to 20. It is the closure property. Next thing to do is to transpose the 12 into the right side. So it will become x is equals to 20 minus 12. And the reason for this statement is transposition. It will become x is equals to 8, and that is closure property. That is how to apply deductive reasoning.
What is problem solving? Problem solving is the act of defining a problem, determining the cost of the problem, identifying, prioritizing, and selecting alternatives for a solution, and implementing a solution.
Problem solving is a mathematical process along with logic, reasoning, and communication. It enables us to use the skills in a wide variety of situations. George Polya, who was known as the father of modern problem solving, he did extensive studies and wrote numerous mathematical papers in 3 books about problem solving. Polya created his famous 4-step process for problem solving. Step 1. Understand the problem. You need to read the problem carefully. Step 2. Devise a plan. You come up with a way to solve the problem. Step 3. Carry out the plan. This is where you solve the equation you came up within your devise a plan step. Step 4. Look back. Check to see if you used all your information and that the answer makes sense.
After considering the possible strategies, is chosen and implemented. If it proves to be effective, a different strategy is tried. People who can define problems, consider options, make choices, and implement a plan have all the basic skills required for effective problem solving. Sometimes, following a step-by-step procedure for defining problems, generating solutions, and implementing solutions can make the process of problem solving seem less overwhelming. Let's proceed the 6-step guide to help you solve problems. Step 1. Identify and define the problem. Step 2. Choose possible solution. Step 3. Evaluate alternatives. Step 4. Decide on a solution. Step 5. Implement the solution. Step 6. Evaluate outcome.
Use inductive reasoning to predict the next number in each of the following list. Letter A, 3, 6, 9, 12, 15. This series of number, what comes next after 15? Here's the solution. Each successive number is 3 larger than the preceding number. Thus, we predict that the next number in the list is 3 larger than 15, which is 18.
Problem-solving strategy is a plan of action used to find a solution. When people are presented with a problem, whether it is a complex mathematical problem, how do you solve it? Before finding a solution to problem, the problem must be first clearly identified. After that, one of many problem-solving strategy can be applied, hopefully resulting is a solution. Bago natin mahanap ang solusyon sa problema, dapat muna natin maunawaan ang tanong o problema para alam natin kung paano ito mabibigyan ng kasagutan. Problem themselves can be classified into 2 different categories known as identified and well-identified problem. Identified problem represent issues that do not have clear goals, solution path, or expected solution. And identify to yung wala ng exact na sagot. Where the will identify problem have a specific goals, clear defined solution, and clear expected solution. As well, identified naman, ito naman yung direct to the point na sagot o may kasiguraduhan. Yun lamang, thank you.
When solving math problems, students should be encouraged to follow a general problem-solving procedure. This is summed up as follows. Number 1. Read the problem carefully. The first and most important step is to read the problem carefully to understand what is being asked or what is unknown and what information you have been given. Number 2. Choose a strategy and make a plan. After we read the problem and analyze what are the given, we can use an organized list, make a table, draw a diagram, and look for a pattern, and etc. Number 3. Carry out the plan and solve the problem. After we find what strategy to answer, solve the problem. Number 4. Review the answers. It is important to review the answers to check for errors. What if may negative signs pala yung final answers? Then, hindi mo nalagyan, so we need to check the answer.
In order to solve the problem easier, we can use the problem-solving strategies like look for the pattern, make an organized list, guess in checked, make a table, work backwards, use logical reasonings, and read the problem carefully. So, here are some problems that we can use the problem-solving strategies. So, first problem is, which of the numbers 4, 5, 6 is a solution to n plus 3 times n minus 2 is equals to 36. So, let's use the number 4. So, 4 plus 3 times 4 minus 2 is equals to 4 plus 3 is equals to 7. 4 minus 2 is equals to 2. So, 7 times 2 is equals to 14. So, hindi na po siya kasi hindi siya 36. So, let's use the number 5. 5 plus 3 times 5 minus 2 is equals to 8 times 3. Since 5 plus 3 is equal to 8, 5 minus 2 is equals to 3. So, 8 times 3 is equals to 24. So, hindi rin po. So, next is, let's use the number 6. 6 plus 3 is equals to 9. Times 6 minus 2 is equals to 4. So, 9 times 4 is equals to 36. So, number 6 po is the right answer.